In your rate law problems, part of the problem will always ask you to find the rate constant and include units with your answer. My students never like to do this, and yet you always have to in order to get full points on your assignment. So typically your professors want you to go ahead and follow the units throughout the algebra when you solve for K. But I have a quick trick for you, which my students find very useful when examining kinetic problems. And here it goes. The units of K will always be time to the -1 power and then molarity to some power x. So how do we figure out what the x is? Well, it's really simple. You're going to have time to the -1 power and molarity to the power x, where x is 1 minus the overall order of your reaction. Now, how do you find the overall order? Simply add up the exponents in your rate law. So, for example, let's say you had a 0 order reaction overall where time was measured in seconds. The units of K would be for a 0 order reaction. K would be seconds to the -1, molarity to the 1 minus 0, or 1, molarity to the 1 power. So the units for your K would be S minus 1, molarity 1. Okay, what if you had a 4th order overall reaction where time was measured in seconds? If it was a 4th order overall, your units of K would be seconds minus 1, molarity 1 minus the overall order, which was 4. 1 minus 4 is -3. So your molarity would be to the -3 power. So the units of K would be S minus 1, M minus 3. Okay, let's try one more. What if you had a rate law that said rate equals K, A to the 1st power, B to the 2nd power? First thing I know, if it says rate equals K, A1, B2, is that the overall order is 3. So if I asked you for the units of K, you would say K is in seconds to the -1, molarity to the molarity to the x power, where x is 1 minus the overall order of 3. 1 minus 3 is -2. So the molarity is to the -2 power, and overall K has units of S minus 1, molarity -2. I hope that helps. Take care.